welcome everybody to the end of either week 14 or 15, whichever it is. So Shapes was due today. I'm actually going to move it back to Monday, but I asked people on Discord for GIF responses only. So we have that, we have that, we have that. This is my first time doing this assignment, so I don't know. I'm gonna consider it a success. I think this was a great success right here. So I'm moving it back to Monday. So I graded the assignment. I actually don't like moving deadlines back, but nobody got 100% on the assignment, so that's an indication to me that the assignment was too hard. We had one person get 10 out of 11, and that was pretty good. But even my best students were usually clocking in at about a 6 or an 8 out of 11. So yeah, that's a sign the assignment was too hard. And so, that's on me, not on you. That said, I hope you learned a little bit about testing code because, it really is a crutch to depend upon your professor to give you all the test cases. Like, a big part of computer science is learning to test your code yourself, to generate test cases, to think about all the different ways the points could be and things like that, and to, come up with your own test cases. Okay? So, the good news for you all is that it will be due on Monday now. And I have now posted all of the test cases so you can actually test your code. So let's go through them and see. Just comment on chat if you are handling that test case or not. So input file 0 is one that I gave to you. This is a line? Yeah, that's like a linear, that's a bunch of points in a line. And so the rule is if you have a bunch of points that are collinear, that are kind of moving in the same direction, then you delete the middle points in between. If there's an angle, you don't pull them out. So you forgot to make your own input tester. Basically, what you do is you type code like that, or not code, just text into a file, and then you run it like this. Input file 0, and you look at the output. Okay. So you just put whatever input you want to go into a text file, use left arrow, and then feed it into your program and see what kind of output you get. All right? And that's a very valuable skill to have. You can use G-Test Suite and things like that, but what we're doing here is called end-to-end testing. So we're basically we're just running the program, feeding input into it, and checking the output and see if it matches. Okay. So that was going to test your ability to remove interior points. You notice the output is just the endpoints there. That's a line segment. The other one I gave you was this one, which is a rectangle, but it's a rectangle that is slightly not a rectangle. And so the rule is whenever you're working with doubles, don't rely upon double equals to work. Double equals is very fragile when working with floating point numbers. The rules of algebra don't apply to floating point math. If x plus y minus y should be equal to x, right? And it might be. It might be. And then you're like, oh, we'll just put a double equals in and we'll test, And then sometimes it won't be, And that's a problem. I once had an infinite loop in my code because I added up a bunch of numbers that were all doubles, and then I subtracted them all back out, and my code would basically loop until it hit 0, and it didn't hit 0. It went right past it. Yeah. And I'm like, how is this possible? I'm adding the numbers, I'm subtracting them back out. It should be 0, and it wasn't. It was very close to 0, but it wasn't 0. And so one of the things that I wanted to kind of reinforce with you all on this assignment is when you work with doubles, you have to have approximately equal to things, or you're going to get burned by it. Okay. So this code here is this input here is a rectangle that is not quite a rectangle, but it's within the margin of error for the assignment, and so you were supposed to recognize that as a rectangle. And all right, so input file 2. This is just a line segment, I think. How many people got this one right, do you think? Input file 2, yes, it's a line segment. Did anybody have trouble doing this one? speak up on chat. This is actually an interactive process. I need to know which test cases you're failing on, because then I can help you with it. Or could you just like not return anything at all? You know. You failed 10 test cases, Holman? No, you only failed 1. You were, by the way, the top student in the class, Holman. So, good job. Everyone clap emoji for Holman, please. Good job. Second place was 8 out of 11. 10 out of 11 was the top. Okay, so anyone have trouble failing this one? No? Pretty easy. You got 2 points. The easiest test case is empty, right? And for empty, all you return, you write something like this, like if vector.size is 0, return make shared empty. Right? Like that's a free point right there. I'll just give that one to you. In your classifier, right? You get a vector of points, and if it's 0, you return empty. Okay. And what I'm trying to teach you though is because your classifier function, right, it returns a shared pointer type shape. Something like this. And I know I'm typing this in a text file, but I don't want to show you the full answer in my code. So the point of this assignment is to teach you about polymorphism, right? And specifically inheritance polymorphism, right? So you have the parent class called shape, and you got 6 child classes that are called empty, point, line segment, triangle, rectangle, and other. And this is a different way of thinking about things. You're returning a shape, but really you can't return a shape. If you were to try and return a shape like this, it wouldn't compile, because shape is a abstract class. It's a pure virtual class, however you want to put it. So the way that it works is when you have pointers, a pointer to a parent type can still point to a child type. And this is how we return 6 different types as one type. Okay? And that's what this assignment's trying to teach you. You have to set up the class hierarchy and make sure that you upload all of that on Canvas by midnight tonight. Even if your classifier code's not done, I want to see all of your screenshots of your class hierarchy by midnight tonight. Okay? And it's all the stuff in it, like area and angles and things like that, they don't have to be operational. You just need to have the member variables in there. Okay? So I inherited a line from point, and all the shapes inherent line instead of point. Yeah, you can do that. It's fine. You can set up your class hierarchy however you want. Yeah, I don't really care, as long as it works. Right? So there you go. There's another one. Like there's 2 points just for free. So one of the things that I try and emphasize in this class is, like, a lot of students like try to go big or go home, right? If I don't get a 10 out of 10, I get a 0 out of 10. And it's like, why are you leaving points on the table, right? Why get a 0 on this homework assignment? The struct empty is going to look like this. String, what's it called? Get type return empty, right? There's your empty class, right? It's going to inherit from. All right, that's all you need for the empty class, right? It doesn't have any members, and it's just probably call that const. Override. There you go. There's an empty class. If you want the point class, something like that. Like. Right, it's not rocket science. Like to just pick up a couple points, that's 2 points right there. It's and if you don't know how to do it, like if you don't understand what this is doing, if you don't understand this, then ask. Ask Minkrelli if you're afraid to ask me, because students oftentimes are afraid to ask their professor because he'll know I don't know the material. Yeah, I know. That's why you're taking the class. If you knew all this stuff already, you wouldn't be in the class, right? I know you don't know it. That's why we're doing this exercise. It's to get practice doing it, and to we're solving an actual problem that actual people in industry are doing right now as a exercise, right? This isn't a professional product, but this is an exercise that corporations are using right now as we speak to train their programmers, their corporate programmers. This is a real exercise, okay? Are you allowed to add member functions to the struct shape? I don't think you should. I guess you could if you had to, but I don't think you need to. So, yeah. I would actually just leave shape as it was given to you. Okay. This helped you out with IO streams and IO streams, something I had trouble with on prior assignments. Yeah. And that's the thing. Like, Cromwell was asking on Discord at 3 o'clock in the morning last night, how do I CN and C out to a point, right? And so there's a pattern, right? There's a pattern, and I have the pattern memorized because I've done it so many times, right? Something like this, but it requires parentheses and things like that too. Arguably, you should use single quote instead of double quote. Right? Yeah, something like that. But the pattern is this, right? And I can do it from memory, but a lot of you can't because it's your first time doing it, right? And so, ask on Discord because I don't expect you to have it memorized. It's like, he'll know. I don't like. I know. That's why you're here. That's why you're here to learn. And I want to teach you. I want to take knowledge and stuff it into your head, right? So, yeah. Banana boat. Interesting. Is that the company that makes the banana boats? It's kind of cool. Yeah. So IO streams, I stream. Yeah. Double left arrow, double right arrow. All that stuff we use fairly commonly. And getting into that habit and using things is actually very, very useful. When slicing happened later because we included points and lines as members in other shapes. Now, if you have a point as a member, it doesn't slice, right? It's like if I were to stuff a point into empty for some reason, this would not slice because it's a point. It's a complete type. Slicing happens when you have a variable of a parent type that's not a pointer or reference, just a variable of that type, and you put a child into it. What will happen is all the stuff that makes the child special gets sliced off, right? So, for example, the x and the y here, they're not in shape, and so if you pass a point to something that takes a shape, like a shape, not a shape pointer, not a shape reference, just a shape, if you pass a point to a shape, it'll work, but all that x and y values get carved off, and it just becomes a regular shape. That's why you always have to work with either references or pointers when you do inheritance, because it does not work with regular variables, with value types. And that's why I don't use inheritance. Because I like my code to have no pointers in it. Sorry, but there's a lot of people out there that love object-oriented programming, and they code this way all the time, and that's why I did this assignment, because it's literally an exercise that people are doing in corporate America right now, and it's all inheritance-based, right? And so you need to learn it. A lot of shops use inheritance quite extensively, and I don't like it because I don't like being locked into using smart pointers, which just add an extra level of indirection to everything. And class hierarchies oftentimes become quite expansive and uncontrollably complicated, and you don't know where anything is or who's responsible for things, and refactoring, it's a nightmare. It breaks everything half the time. So I used to do a lot of object-oriented programming, and now I just kind of don't, in my own thing. I saw people use pointers in inheritance. I was wondering I was doing it wrong because my main has no pointers at all. Let's take a look. Let's not save this. Okay. Interesting color scheme, huh? So let's look at your code. Get vector points, inner point, you see into it. If you broke something, it breaks. Otherwise, you add it to the vector, increment your count. Your formattings should be formatted like that, huh? All right, fine. There you go. How do we detect collinearity? Great question. And so, Mincarelli, you want to? Is he here? He's not here. Yeah, we can go over that in a second. I was hoping somebody would ask on Discord, because checking for a right angle and checking for collinearity, which is actually the same code, is actually a very common thing we do in code. You can do trig if you want, or you can use linear algebra. I was waiting for somebody to ask, and nobody asked, so I didn't say. It's not hard. It's 2 multiplies and an add to do it. Dot product is exactly correct, yeah. But we'll go into that in a second. So, all right, point count. So you didn't write a classify function at all. So that actually is non-responsive to the assignment. You have to call classify and get a shared pointer back. That's actually something you have to do in the assignment. So this would not count for the 5 points. Okay. You might pass some of the test cases, but you're going to lose points for not actually doing the assignment, which was to practice making a class hierarchy and returning a shared pointer and having inheritance. So, is it valid to test rectangles by comparing distance between opposite corners instead of checking for right angles? Would that work? Maybe. Would it work with a parallelogram? Maybe. I think your code might not work on parallelograms. I'd have to think about that though. No, because the diagonals would be different, wouldn't it? Yeah, you could probably do it. You could probably do it that way. Yeah. Okay. Anyone else want me to look at their code? Give helpful suggestions and things like that? So my main down here. Friday Night Functors. Let's see here. So here is the dot product, and I'll explain that to you in a second. So basically, in my main, every time I read a point, I check the last 2. So I go back 1 in the vector, and I go back 2 in the vector. And obviously, you can only do that once you're on your 3rd point, right? If you're on your 1st point, you can't do a collinearity test because you're on your 1st point. 2nd point, same thing. They're always going to be linear. So once you're on the 3rd point, then you go back 1 and go back 2 into your vector and check to see if the 3 lines are collinear. And if they are, you delete the middle one. Okay? Collinear and in the same direction, I should say. Collinear points in the same direction get dropped. So we look at the current point, the previous point, and we do a dot product between them. If the dot product equals 1, they're in a straight line. And by equals 1, I mean is close to 1 because we're doing floating point math. So check to see if you're in the neighborhood of 1. And if it is, then I delete the middle one, right? So the last person in the vector gets popped off, and then it's now just the first and the last. And then when you add another one, if that's still collinear, it pops this one off, and so on and so forth. All right. You never got hash and operator to work. You can always just write a function. You can always just write a function, just pass that as the second parameter to the unordered set. Set. Right, so this thing here is a function that takes a point and returns a hash value. You just write a function for it. You don't have to do the weird operator open close parentheses thing that I did. Okay, so yeah, so dot product. Let me switch to my Microsoft OneNote here. Set 41, new page, and this will be called Linear Algebra. So if you have a vector and you have a vector and they're going the same way, the dot product equals 1. If you have a vector and another vector at a right angle to it, or the other right angle, it doesn't matter, the dot product is 0. And if you have a vector that's going one way and a vector that's going the opposite way, the dot product is -1. And that only works for normalized vectors. Normalized means length 1. Yep. So how is test 8 not a point? Let's take a look. What did I change? Did I change something? Make file 8. That is not a point. There are 2 points that are the same point. And so this is other. If you have a line segment where the ends are on the same point, that's not a point. That is a other. Yep. That makes sense? If you have duplicate points, it's almost always other. The only duplicate point allowed is when you have a closed loop and the first and the last point are duplicates. That's allowed. Any other duplicate is automatically going to make it another. Okay. And they are close to each other. Yes, they are close to each other. It is a smidgen off. And so again, this is testing your ability to use the is near function. Right? Okay. All right. So if you have a rectangle, you can think of it as and the points are always in, this direction, right? Well, it doesn't matter what direction. They're in order, right? And so point 0, point 1, point 2, point 3, and also point 4. Point 4 and point 0 are the same. Now you want to see if this is a rectangle or not. So what you need to do is see if this is a right angle, see if that's right angle, and see if that's right angle. If those 3 are right angles, you don't actually have to check this one because it's a quadrilateral and it's got 3 right angles. The last one has to be a right angle also due to the powers of subtraction. So a duplicate is, duplicate, anytime there's a duplicate anywhere in the system, it's going to be other unless it is this case here, where the first and the last ones are the same. So a line segment with 2 points the same is technically other. Okay. So yeah, you can, if you check 2 of them, that probably would work. Yeah, because that means these 2 are equal. Yeah, that should work too. Okay. So anyway, so let's do this. So how do you check to see if this is a right angle or not? Well, there's one thing here, and that is from point 2 to point 1. So vector square bracket 2 minus vector square bracket 1. Let me erase that and write it in a way that's more human readable. So we've got our vector of points 2. Lord, don't write and speak at the same time. Vector 2 minus vector 1. That creates that creates this point, this line here. Okay, and you want to normalize it. Okay, so it has a unit length. Actually, in this case, it doesn't matter. So who cares? Because if you get 0, you get 0. But for most dot products, you want to normalize it. And normalize, if you have a vector like this, that's 3 and 4. This is a length 5 vector, right? To normalize the vector, you divide it by 5. So you divide it by the length. So to normalize a vector, normalize means you make it of unit length of length 1. So you take the vector and you divide it by the length of the vector. That's how you normalize something. In this case, you don't need to do it. All you need to do is subtract 2 points from each other, this point here and this point here, and that gives you a vector from 1 pointing to 2. How do you do subtraction? Well, 3, 3 minus 1, 1 is 2, 2. Okay? Vector addition, vector subtraction are very simple things. If you want to do vector addition, 3, 3 plus 10, 10 is plus is 13, 13. Okay. You do not anticipate math 6. You can also do this with trig. If you take the arctangent, you can get the angle that way. But linear algebra is simpler. Operator plus. So you can see right here inside of my point class, I have a plus operator that will add 2 points together. I've got a minus operator that subtracts the 2 points. And so what it does is it creates a new point. It creates a new point whose x value is the left-hand side's x minus the right-hand side's x, and whose y value is the left-hand side's y minus the right-hand side's y. It's this, right? I'm teaching C++ how to do linear algebra. Okay, so we can call this guy the left-hand side, call this guy the right-hand side. So his x minus his x is 2, his y minus his y is 2. That's the return value. So that is how you do it. Okay, right there. All right, so, and then this vector here is vector 1 minus vector 0. That's this vector here. And if you dot product the two of the things, then this is the equation to get if it's a right angle or not. So if this whole thing here equals 0, then it is a right angle. You compare the slopes to multiplication. Yeah, you can do that. You're only going to have trouble if you have a vertical, all right? So vertical lines are kind of annoying. Why are you not drawing? Weird. Undo. Thank you. Control Z wasn't working. Okay, so how do you do? What is dot product? What is this thing? How do you multiply two vectors together? As it turns out, there's actually 3 different ways of multiplying vectors. There is the dot product. There is the scalar cross product. And there is the vector cross product. These two we don't care about for this class, for this assignment. We're only going to talk about dot product. And so the equation is actually pretty simple. x1, x2 plus y1, y2. And then this will give you a number, like I said, 1 means they're pointed the same way, 0 means they're at right angles, -1. 1 means they're going in the same direction. 0 means they're at right angles or perpendicular. And -1 means they're going in opposite directions. And it's a smooth continuum. So you could get a dot product of like 0.7 or 0.5. Basically, when they're pointing in the same direction, you get 1, 0.9, 0.8, 0.7, 0.6, 0.5, all the way down to 0. And then you get -0.1, -0.2, -0.3, all the way down to -1. Okay. And so is dot product used in video games? Yes, it is. That's why I teach dot product in video games, and cross product, actually, for that matter. Cross product tells you if something is to the left of you or something is to the right of you. Dot product is useful to know if two things are looking the same way. For example, if you're going to backstab somebody, if they're looking the same way that you're looking, it's a backstab. Cool. And you typically will set up like a cone that you can backstab in, right? So, you know, if it's like greater than like 0.7 or something like that, then it's a backstab. So it doesn't have to be exactly 1. You're just mostly behind them, it's a backstab and does double damage or whatever. So, what if they have the same slope but move in opposite directions? Yeah, you would need to handle that. The dot product handles that, though. So if they're in opposite directions, the dot product will be -1. Okay. And you have to normalize the vectors first. Do you guys know how to get the length of a vector? So if you have a vector whose x component is 3 and whose y component is 4, do you know how to compute the length to get 5? Right? Pythagorean theorem. Yeah. So the length of a vector is the Pythagorean theorem. In C++, this is known as hypot, or hypotenuse, or maybe because it was 420 2 days ago, it might have some other meanings to some of you. I don't know. So, yeah, so you pass in x and y, and it gives you the hypotenuse there. And so you just divide by that. And that will normalize the vector I can show you my code for that. So I got normalize, so I get the length of the vector, and then I divide the x by the length and the y by the length, and that will give me a unit vector, a unit of length 1. You don't have to do most of that. Like I said, you don't have to normalize to do right angles, because 0 is 0. It doesn't matter how big the things are. It'll give you 0. Oh, wow. That just exploded my code. Comparison. This is something that a lot of people have trouble with as well. When you do comparison, you can't do exact equality, because we're working with doubles and floats. Exact equality is danger, right? What you want is close to something, right? And so whenever you work with floats and doubles, you want to write something like this. I don't care what you call it, but something like this that will say it's approximately equal to each other. And that just does an absolute value of the difference and says if it's less than the margin of error, epsilon as we call it, then it's true. Operator plus is a different shade of yellow. Is it? Huh. Looks the same on mine. Weird. Huh, okay. Yep, so I can add points together, I can subtract points. This is doing dot product, and it normalizes them first, so this will always give me a number from -1 to +1. This compares 2 points, this sees if 2 points are not equal, and you notice that I'm using the equals operator to determine if they're not equal, rather than rewriting it from scratch. I've got here a double right arrow, a double left arrow, so this is a fairly fully functional point class. The one thing I'm missing is a less than operator, so that I can't put this into like a BST or something like that, because BSTs require the less than operator defined. I can't sort them because sorting them also requires the less than operator to be defined. But I also don't know what it means to sort points, so until I need it, I don't write it. Here's how you do hash. So there's your code to do hash. This is a garbage hash function, by the way. But what it does is, given the x and the y value of a point, it figures out what bucket it should be, right? So it takes the x value of the point, multiplies it by 1,000, and adds the y. So if you pass in 0.11, it hashes to bucket 1001, right? It's a garbage hash function. The reason why it's garbage is because you're going to get tons of collisions, especially if the numbers are along that, like you can visualize this as a line, right? And if you hash everybody along that line, they'll all hash to the same bucket. You'll get tons of collisions and your performance will suffer. But at the same time, I'm the person who makes the test cases. So I know it's not going to be a problem. So I just, the only thing you really have to make sure of when making a hash function is that it's repeatable, right? Don't use a random number in there, because then you'll insert it in a bucket, and the next time you hash to find it, you go to a different bucket, and you're like, oh, it's not there. And so the main requirement for hash function is that it is consistent and reliable and always gives you the same bucket for the same input. Okay. So were you supposed to use a hash table? No, you don't have to. It's faster though, because a lot of people did like an order n squared comparison, where they like, for every point in the vector, check to see if there's a duplicate point. That's order n squared. My version is order n. So I was thinking about adding a test case that would time out if you were doing an n squared algorithm, and I might still do that for part 2. Okay. So, yeah, if you have a hash function for your class, then you can put it into an unordered set and it'll work. Okay. You guys ready for part 2? Coming on Monday. I'll give you like a day or 2 to do it, don't worry. And then these are, I made I don't know why I need that. I think it's just demoing to my students that you can treat a point, so like you can have like point P, right? And then you like see out P like that. And that's going to see out the length. I don't think this is good code, because like it doesn't make sense, but you do that. I defaulted the copy constructor and I defaulted the assignment operator. that just uses the ones the compiler makes for you. Okay. So there's my point class. You can copy all that if you want. Don't copy the comments though. You'll lose points if you copy the comments. Okay. You guys excited for part 2? Where we're gonna take the worst student submission, and you get to work with that to implement the computation for areas and things like that. But you're gonna be getting a version that gets 10 out of 10 or 11 out of 11 because there's 11 test cases right now. So you're going to be getting a working implementation. So that's good. Yeah, that's good. All right. Comment out in the comments. So, yeah. On Monday, we can have a little competition to see whose code's the ugliest. Then we'll throw it up on GitHub and let everybody clone it. I think that would be fun. And so you have a benefit. If you have the ugliest code, you know what it does. Cool. All right. So make them ugly. Make them inefficient. Okay. All right. Yeah. So that's basically that. Let's see if there's any other test cases that are interesting. So that is your basic rectangle there. Okay. Wait, are these the same? Oh no, this is not a rectangle. This is very close to a rectangle, but it's not a rectangle. So this test case is testing to see if you are doing right angles properly. 5 is empty. Hopefully you all got that. Like I said, there's some of these test cases are just designed to be free points. Like here you go. You spent 5 minutes working on this assignment. Here's a point, you know, and here's a point. It's literally a point. It's a point, right? So get a point. Here, free points. And a lot of people had code that didn't compile or got zeros, and it's just kind of like sad face, right? Like just, you know, even if you only have, like, you got physics midterms or whatever, just like spend the 5 minutes to at least, you know, get a couple points. You know, it's better than 0. You know. Wait, I only have 2 inputs. I don't know. How many did you make? So this thing here, I think, is a triangle. It's a regular triangle. Yeah. This is a 2 points that are the same point but close to it. That's an other. This one here is collinear, so it's going to test to see if you remove collinear points. And it's still a triangle, I think, or something. No, I think it's other, actually. It's not closed. Yeah. So this one's not a closed. It's just an open line, so it's other. File 10. And then this one looks like a rectangle, but the points are, it goes 1, 2, 3, 4, 5. And so all the angles are right angles, and there's 5 points in it, and it's a closed line, but it's not a rectangle. So I'm going to redo the test cases for Monday, so you will not have these exact ones to test, but that'll give you an idea of what I'm looking for. So I did push out the input tester about an hour ago. So you can now go over the actual test cases or close to them, and see how you're going to do. So that'll be due on Monday, and then we will do part 2. All right. So you should have the email with the grade. Yeah. Okay. So let's talk about bit operations. There's a few more that we didn't talk about before. Switch the color scheme to dark mode. Yeah. Okay. So there you go. This is, my mom always thinks I'm working with 0s and 1s, and so there you go. That's how I program right there. I have a keyboard that only has 2 keys on it, 0 and 1. I just go like this the whole day. So, our next topic is bit fields, bit sets, bit operations, however you want to put it. Bitwise operators, they're sometimes called. If you know the tech hub downtown Fresno, that's called Bitwise. It's named after this stuff here. And basically, it's treating an integer as 32 booleans, right? So if you need more, you can use a 64-bit. Unsigned 64-bit gives you 64 booleans. Kind of cool. And so you need to learn how to mess with them. Last time we talked about insert, search, and delete. Today we're going to talk about a few more things. All right. And so we're going to first go over how binary numbers work, because a lot of students don't actually know. Let's call this binary numbers. And I want this to be a little bit interactive. In the previous class, I had Aaron come up and solve these things on the board, and other people work on the board. But you guys are just going to have to post onto chat. Okay. So in tens, base 10, our normal counting system, right? What is this digit called? Do you guys remember what this digit here is called? Think back to like 3rd grade math. What do we call that digit right there? Can you remember 3rd grade? It's a long time ago. Probably longer for me than for you. The ones digit, yeah, that's the ones digit. What's this one called? Hundreds? Tens. This is the tens digit. What about this one? Hundreds. Yeah. Okay. And so if you look at it, it's 10 to the 0th power, 10 to the 1st power, 10 to the 2nd power, so on and so forth, right? So you can think of this as 10 to the 0th, 10 to the 1st, 10 to the 2nd. Clean up that 0 a little bit there. And so, do you guys remember doing this like back in elementary school, how they would say like, okay, add 20 to 400, Do you guys remember this kind of thing where you'd like have to separately add up the hundreds digit and the tens digit? You guys remember that kind of stuff? Okay. So binary is the same way, except instead of tens, we use twos. It's base 2. So this system here is called base 10, also known as decimal. Okay. And binary is the same, except we use powers of 2 instead of powers of 10. So binary. That's what we're going to learn. And the only digits that are possible in binary are 0s and 1s. So if we have 10101, then this is 2 to the 0th power, 2 to the 1st power, 2 to the 2nd power, 2 to the 3rd power, 2 to the 4th power. Okay. Also known as 1, 2, 4, 8, and 16. Okay. And so if I were to ask you what is 10101 in binary, convert that to decimal, then what you do is you do the same thing you did before, right? So that's 16. So it's 16 plus 4 plus 1. So 21. Oh. And so hexadecimal is base 16, right? So base 16 is called hex. I don't want to write it hexadecimal. There you go. Okay. Right? And so 420 in hexadecimal is 16 to the 0th power, 16 to the 1st power, 16 to the 2nd power. And so what happened here? Okay. So 16's just switch into programmer view. Okay, let's go to hex, and if we type 420 in hex, that is 1056 in decimal, or 10000100000 in binary. Give or take a 0, I'm not sure, I lost count. Okay, so 420 in hex is 1056 in decimal, because that is the 256 digit, that's a 16 digit, right? So it's 4 times 256 plus 32. Yes. Okay. 1024 plus 32. Yeah. Okay. All right. Why do some binary lines start with 0x? Because in C++, that means hexadecimal. If you have a regular, it's a decimal. And in binary, the The way that you write a binary number in C++ is this, 0b, like that. Okay. And so 0b10 is the number 2. Right, you guys see that? That's the 2's digit, that's the 1's digit. So 2 plus 0 is 2. That makes sense? And I love to trick my CSci 45 students with this. Why do they start with O letter? Because that's just how it is. Because regular numbers don't start with an O, right? So if I were to write O50, that's not decimal. Anyone know what that is? Anyone know what number that is? In decimal? It's 40. Okay. A leading 0 means that it is in base 8. Okay. So a leading 0 is base 8. So let's put this over here. This is called octal. Octal is base 8. And so you can have like 050, and so that is 1's digit, 8's digit, 64's digit. Right. And so 5 times 8 is 40. So there's different prefixes, and that indicates the C++ which base you're talking about. 0x is used for memory addresses by default. By default, all memory addresses are outputted in hex because it's more concise. You could write any memory address in 32-bit or 64-bit binary, but then you're writing 1100111100110011, and like you know, it's obnoxious, right? Every hex digit is 4 binary digits. So for example, 1111 is F. 0B1111 is F. This is just the prefix, this is just the prefix. It doesn't mean you're multiplying F by 0. It just means this is a hex digit, right? So F, this is hex, right? So this is 15. Yep. So yeah, in hex you count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Okay. So those are the 16 digits available in hex. The regular 0 to 10 plus A through F. Okay. F is the maximum digit in hex. After that, you get 10. Right? So you count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 1A, 1B, 1C, 1D, 1E, 1F, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 2A, 2B, 2C, 2D, 2E, 2F, 30. Okay, that's hex. Okay. Octal counts from 0 to 7, then you get 10. Binary, it's 0, 1, 10, 11, 100, 101, 110, 111. You guys feel good about that? Here, let's do some more. Let's do some more. You don't have to worry about these things right now. Just binary. So let's do 0, 1, 0, 1, 1. Okay, what number is this? This is binary. Put the prefix here. It's 8 plus 2 plus 1, right? So our 8's digit is set, our 2's digit is set, our 1's digit is set. This is 11. Okay. What if we left shifted them all 1 bit? Double left arrow is the left shift operator. What happened if we moved the 16 to the 32-bit, the 4 to the 8-bit, the 1 to the 2-bit, and put a 0 at the last? This number right now is 21, right? What number would we get if we left shifted everything by 1 bit? What number is this? And can you do it without doing addition? Yeah, every bit doubles. And so what does that do to 21? 21 becomes what number? 42. That's right. And so 42, the answer to life, the universe, and everything is literally lol, 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 lol. There you go. So every time you do a left shift, you're doubling the numbers. And this actually matters because when you take assembly in fourth semester computer science, you learn that multiply instructions take 4 cycles. But a bit shift takes either 1 cycle or sometimes 0 cycles because you can actually include a bit shift into another operation. So it actually has no overhead whatsoever. And so rather than spinning 4 cycles, the 4 cycles means your CPU has a clock that goes up, goes down, goes up, goes down. Every time it goes up and goes down, you can do like an addition, right? It goes up, goes down, you do another addition, right? Multiply takes 4 of those, right? So it's 4 times slower than arithmetic, adding and subtracting. Division takes 80 cycles or so. Depends how you do it. Depends on the hardware. But can you guys think of a way of dividing 42 by 2 that doesn't require 80 cycles? How can I divide 42 by 2 and get 21 without actually doing this very complicated instruction to divide 42 by 2? Right? Yeah, right shift. Double right arrow 1. That will move all the bits to the right. A lot of students ask, well, what happens if you have a 1 here, right? Like, what happens to that number, right? What if you had 43? What is 43 divided by 2? Yeah. What do you get? Well, what happens is that shifts off. This is a cliff, and there's water down below, and the thing goes, and it falls into the lake, or the ocean, or whatever, and it dies. So anything that shifts off the edge of the thing goes away. It goes to the bit bucket in the sky. If you take assembly classes, you'll learn there's ways of salvaging that sometimes, but basically in C++, if you do a right shift by 1, it literally just does this. Doop. And then 43 turns into 21. Makes sense? And you might be asking, like, wait, isn't this the input operator? You know, you like to see out, double left arrow, you know, like, isn't that like output? And, you know, CN double right arrow is input? Is that stream extraction, stream insertion operator? And like, what? And what happens if you shifted it back to the left? You get 42. This is what happens. Like that. And it always fills in as 0. So if you right shift and you left shift, then 43 would turn into 21, which would turn into 42. So if you take 43, you right shift, you left shift, you get 42. Okay. Another way you could do that is you can say X ANDed with F, 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 E. So if you AND it, these are all 1s with a 0 at the end, and then that would drop the last bit and turn it into 0. Be a little bit faster than doing a left shift and a right shift. So you can bit mask out the last bit if you want to drop that and set the last bit to 0. Another way of doing that would be, that might be a little easier to understand, be X ANDed with the bit negation of 1. So all the bits except 1 turn into true, the last bit turns into false, and then you AND it with a whole bunch of 1s and a 0 at the end. And then that will drop the last bit to 0. If you keep shifting, you will get 0. Yeah. And so, you know, if you want to have job security, you know, the you know, losers write code like this. Right? That is not going to give you job security. Right? This is how you do job security. Same code. It's still end x equals 0, but you have job security now because nobody's anybody who looks at that is going to be afraid to touch it. They're like, I don't know what he's doing. We just can't fire him because it's there for a reason. And if we change it, it'll break everything. Right? So, there you go. Yeah, exactly. Only, this is what you look like when you write that code. All right. Right? And then you got int y that's equal to 2 right shifted twice, right? If you right shift it once, you get 1. You right shift it again, 1 divided by 2 is 0. So this is the same thing as saying int x equals 0, int y equals 0, but they can't fire you now because they have no idea why you're doing this. If you shift all the numbers to the right and shift back, yeah, you just get zeros, right? So, yeah. So this number here is 0, and then you can left shift it 4 times if you want, and then that will give you 0, because 0 left shifted is 0, you know? Or you can take 1 and left shift it, 50 times. That's also 0. Right? So, yeah. This is how you don't get fired. Or maybe they will fire you because they look at your code and they're like, okay. Can you do math with a binary number and a hexagon number or a regular number? Yeah. They're all the same thing under the hood. The only question is how they're represented in text. Right? So like, under the hood, it's all 1s and 0s. Right? But it's, you as a programmer are like, I want to see the number in hex. I want to see the number in binary. I want to see the number in decimal. And certain numbers default to certain formats, right? So, what number is this? 10? I already have an X. Lord. Y. Fine. 42. All right. So, yeah. What if we right shift it by 1? What do we get now? Holman, you ready? 10. There you go. Okay, you're already on that. Yep. So 21 divided by 2. This is just a... right. But it does it in 0 cycles instead of 80. What if we do that? This is equivalent to 21 divided by what number? I'm not asking for the final result. I'm asking you what number we're dividing by. So if right shifting once is division by 2, the right shifting twice is division by 4. Right shifting 3 times, is that division by 6 or is it division by 8? The pattern is unclear. 2, 4, 6, 2, 4, 8. The geometric or arithmetic progression. It's 8. All right. Every time you right shift, it's division by 2. So divide by 2, divide by 2, divide by 2. It's division by 8. Okay. Can you do, yeah. So we'll do 21, right shifted once, quantity minus 10. All right. And order of operations matters. There we go. So we got a 0 here. What if we write this number in hex? You guys know that you can do that? If you see out hex, it will output the number in hex. Check it out. This is 0 in hex. Cool. Maybe let's pick a different number. 21 left shifted once. And there we go. Got 2A. So you have 10 in the ones digit. You have 32 in the 16 digit, right? Or 2 in the 16 digit, which is 32. 32 plus 10 is 42. Okay. Does it change all the outputs to hex? Let's find out. Where is Mas? Yeah, there we go. Here. Let's do 1 left shifted 5 times. What number is this? One left shifted once is 2. 1 left shifted twice is 4, 8, 16, 32. Yeah. I think. Let's find out. And yeah, it's in hex. So this switches C++ to printing in hex, right? So does that work? Deck. And now we got 32 again. All right. All right. What else could we do with this? So that's left shift, right shift. We did and or not. Did we do not last time? All right. Let's do this. Equals 1. Let's output the not, binary not of y. So what that means is that all the 1 bits become 0 bits, all the 0 bits become 1 bits. So what are you going to see when we do this? Y is 1. A huge number. Is it? Is it huge? 0? So in binary, this is the same thing as if I'd written there. That's 1 in binary. Now I could drop the leading ones, but this kind of gives you the point. So if we flip all the bits, all the zeros become 1s and the 1 becomes 0. So that number is not 0. Okay. So what number do we get? Now we're printing in hex, remember? So in hex, int z equals this is the equivalent of that in binary, right? 1111 is F. So we're flipping all those bits. So what are we going to see? The last digit's going to be an E, because it's going to be 1110. 8 plus 4 plus 2 is 14. 14 is E. What are all the other digits going to be? There won't be any 1s in there. Yeah, in binary they're 1s, but we're printing it in hex. So what are we going to see? The whole point of hex is to not write 32 1s and 0s like this because it's annoying, right? Yeah, very good, Carlos. It's going to be 4 Fs and then 3 Fs and an E. So 7 Fs and an E. Okay. Unless I screwed up. Which never happens. There. E. Okay. All right. 1, 2, 3, 4, 5, 6, 7 Fs. Very good. Okay. All right. What is it going to print now? What's it going to print? It's not E. E is the last digit, right? If the last digit is 1, if the last digit is 1, the bitwise not of 0001 becomes 1110. Right? But we're bitwise knotting 1000, which becomes 0111, which is 4 plus 2 plus 1 is 7. And so this is actually something that we see very commonly when you're outputting a pointer. If you want to output a pointer, like if you want to see out the address of y, it is probably going to look pretty similar to that number, actually, right? See that? 7FF. Okay. So why? Because that's the top of memory. The top of memory is at 7FFFFFFFF. And so you can see it's down a little bit from the top of RAM, because that's where the stack is, right? So stack allocated variables are going to usually have a 7FF in them. And so by looking at this hex code, I don't care about, the 6B, like I don't care about that. But just by looking at this and be like, okay, that's a stack allocated variable by just looking at its location in RAM, right? It's like when you're in the matrix, right? Whereas if we knew something, like we see out new int, we're to immediately leak memory, right? If you see out something on the heap, you can see it's actually much lower in memory. And then we immediately leak that memory because we don't catch that pointer anywhere. But you see that? So just by kind of looking at, if you understand hex, and like you're in a debugger and it's like complaining about a pointer, like just by looking at, the numbers of the pointers, I can tell, oh, that's a stack variable, that's a heap variable, that kind of stuff. Okay. Kind of cool. All right. Now, let's talk about left shift and right shift. We kind of did that already, but let's talk about XOR. Okay. Int, where do I have an X? Int y again equals 0b1100, and int z is equal to 0b1010. See out binary y and z. What's it called? Does it not support it? No, either way. We'll just output the number. So this is 12. This is 9. So what value is going to be the bitwise AND of the two of them? As audience participation, I have plenty of coffee and I got a boba. So I'm more than willing to just sit here and wait for people to answer. So what you do is you go through each vertical column of bits, right? So the first bit, second bit and the second bit, third bit and third bit, fourth bit and the fourth bit, and you AND them together. And then you post onto Discord so I can stop staring at you and strumming my guitar. So let's solve this. If you remember this last time, true ANDed with true is true. True ANDed with false is false. False ANDed with true is false. False ANDed with false is false. The answer is 8. do the same thing with bitwise OR. Post on to chat, please. The bit pattern. Sure, but what number is the bit pattern? Not the bits. Tell me the number that's going to be output. Oh, the noise suppression. That's unfortunate. No. All right. So this is going to be, when you do OR, you look at the two things. True ORed with true is true. True ORed with false is true. False ORed with true is true. False ORed with false is false. So this is 8 plus 4 plus 2 is 14. Okay. Now let's do XOR. So the rule for XOR, which is exclusive OR, one side is set but not both. Okay? And exclusive OR is actually how we use OR in English a lot. Logicians use inclusive OR, which means either or both. In plain English, though, if we stress our word a little bit, then it means exclusive OR. Like when your parents ask you, do you want pizza or spaghetti for dinner? The logician says yes, and then your parents are like, don't be dumb, which one do you want? You know, because we're asking a exclusive OR, not an inclusive OR. Do you want to go ice skating or do you want to go to the arcade? Yes. Now, it's an exclusive OR question, right? Or. I stressed it, it's OR. Exclusive OR. If both are true, it's false. Okay? So, with exclusive OR, if both sides are true, the answer is false, and otherwise it works like OR. Okay? So this is, in fact, yes, 1, 1, 0 like that, or 6. Okay. Now, one of the cool things about exclusive OR is that it is a reversible operation. It is the only one of the basic operations that if you do it twice, you get the same number back. And the reason for that is because you can think of the 1 as meaning flip the bit above me, and 0 meaning leave the bit above me alone. So you can see here, this 1 flipped that bit from true to false, this 1 flipped that bit from false to true, and then the zeros left the numbers above them alone, and just pass them down. And so if you use this in cryptography, all the bits that are 1s flip, all the bits that are 0 are left alone, and so if you have a random pattern of 1s and 0s, I have a copy of it, Stover has a copy of it, I can take my email, XOR it with those bits, create a garbled gobbledygook message, send it over the internet. Anybody in the world can intercept it. It doesn't matter. They can't read it. Only Stover can read it because he has the same bit pattern I have. He XORs it against the secret, the secret pattern that we've already shared, and he gets the email back. This is a cryptography system called a one-time pad. And we'll talk more about that in CSI 26. It's an unbreakable system except when you reuse it or if your numbers are not random. So if we do something like this, right? If we XOR it with 1010 again, that's Z, right? Then we will get true, true, false, false, right? False XORed with true is true. True XORed with false is true. True XORed with true is false. False XORed with false is false. And so you can see we get our original number back. So if you do this, you will get 12. Oh, it's reversible. All right. And contrariwise, if you do this with Y, then you get Z back. Yep. So you will get 9. And in fact, that's how doubly linked lists store one pointer instead of 2. They XOR the two values together. And when you come in from the left, you XOR the double pointer with the left value, and it gives you the right value. And if you're coming in from the right, you XOR the double value with the right value, and it gives you the left value. So you only need one pointer to store 2 pointers. Cool stuff. So, yeah. So doubly linked lists are just better than singly linked lists. The only benefit singly list has is that it's one pointer instead of 2, but using XOR, you can actually have a double pointer. So you store both of them together and you XOR whichever direction you came from, because you know that address, you're already there. You know, you have a pointer at it. So you XOR it with a double pointer and you get the other one. It's cool stuff. All right, so it returned 10. It returned 10? Did it? Yeah, right? No? Yes, that is not 9. That is, in fact, 10. Thank you. Right. Okay. Yeah, thank you. Okay. So 8 plus 2 is 10. Okay. So, yeah. So if you have a double pointer, if you XOR it with Y, you get Z. And if you XOR it with Z, you get Y. It's cool. It's cool stuff. There's a lot of cool tricks you can do with that. In fact, you can use this to swap two values without a temporary. So if you have two integers and you want to switch their values, normally you make a temporary, you move one into that, and that into that, and that into that. But if you use XOR, you can actually XOR them together and actually swap their values without using a temporary. And when my professor told me this, when I took CSci 40 and 41, he said, yeah, there's a way of switching two variables without a temporary. It drove me crazy because this was at a time, when the internet was still in its infancy, and I was trying to figure out how the hell you do that, and it bugged me for years because he didn't tell us, And I was like, I remember driving home just thinking about it, like, how you do it. And I figured out a way of doing it using algebra, right? You add the two numbers together and subtract them and stuff like this. I actually worked out a different way, but you can do it using algebra, in fact. But XOR can do it as well. All right. So, yep. And then we got binary negation. We already did that. Okay. So left shift, right shift, binary negation. Now, one of the reasons why C people hate C++ is because this is the left shift operator. And so this is not actually the output operator, this is the left shift operator, and it has the same order of operations as other bit operations. And that's why you see me putting these parentheses around the thing here, because if you don't, then your code don't compile no good. Check this out. Compilation error. Right? Why? Well, if you have things that have the same priority, you do them left to right. And so what this code is equivalent to is this. Now, can you left shift C out by an integer? Is there an operator in the C++ language that tells you how do you left shift an object of type OStream? Is there such a thing? Because C out is an OStream, right? Can you left shift an OStream? Is there an operator double left arrow that takes an int and an OStream on the left-hand side? Is that defined in the language or the standard library somewhere? What do you think? We have Holman going with no and a bunch of people too scared to be wrong. Just post your guess. You're not going to lose points for Gryffindor if you get wrong. What do you think? Let's find out. Yep, seems to work. Right, it's the output op. That's first week of CSI 40. They have overloaded the left shift operator for OStream on the left and int on the right. This is part of the standard library, in fact. They wrote an operator double left arrow for it. So if you left shift a OStream, it will take the value of the integer and output it to the screen. And this frustrates C people because this is the left shift operator, it's not the output operator, right? And so the reason why this code doesn't compile is not because of this part here, but it's because of this part here. So what does operator double left arrow return? Anyone know? What is the type returned by operator double left arrow? Anyone remember that from the pattern? Yeah, it returns an OStream. Right? So what value is returned by cout double left arrow y? What gets returned from this expression here? What value does it return? Y? Does it return cout? What does it return from this expression? this code compiles fine, right? Yeah. And so if you do this code here is actually exactly the same as what I had before. So it couts y, and then it returns cout, right? Like when you write this, it's returning an O stream, right? It can't return y, it's returning cout. And so every time you do a cout, it returns cout as part of the expression. And so when you say cout double left arrow y, it returns cout. And the reason why it does that is because it then parses down to that. Cout z. Okay, so we couted y first, then we cout z. Cool. And then that will parse down to this. And it will cout inline. Okay, and so that the reason why it returns an O stream is so you can chain together multiple double left arrow statements like that. Now, what's happening here? How is this going to parse? What is cout double left arrow y caret z going to do here? How is that going to parse down? Drink some coffee. Think about it. And why is this not compiling? It made the C gods angry. Yeah, no, you're right. So cout double left arrow y returns cout, right? And so it parses down to this. Is there an operator caret defined for C? No, there's not. And that's why when you do this, the code doesn't compile. And this is why C people are angry, because it, like, you'd want to be able to have this work, because y caret z, it returns a value and you should be able to output it. But you can't, because Bjarne chose to overload a bit operator, and you can't change the order of operations from C without breaking backwards compatibility. And so every time you want to use a bit operator in a cout statement, you have to wrap parentheses around it, otherwise it won't compile. Okay, you guys with me on this? Makes sense? So if you do it this way, it'll compute y XOR z, and then it'll cout the result, and then it'll cout inline. You guys cool? Yeah. All right. So let's talk about what you can do with bit shifts. So let's say that you've got let's throw some things in here. I don't even know what number that is anymore. And you want to find where the first one is, right? For example, let's say that you've got all these. Let's say that you've got all these weapons here. No, he can't. There's no way you can change it, right? Like, you can't break backwards compatibility. It would defeat the entire purpose of C++, which is that people put up with it because it's got backwards compatibility. Right, so let's say you got all these weapons, and you want to find what your best weapon is, right? Like, the rocket launcher is better than the lightning gun, and they're in... And this is actually how it is in Quake. The weapons are actually ordered from worst with the lowest number to best with the highest number. And you could probably argue whether or not... Actually, I think lightning gun is actually higher than rocket launcher, but you could argue that the rocket launcher is better. I don't know. And it does this so that if you're running around with a single-barreled shotgun and you pick up the super nail gun, it switches your weapon automatically into the super nail gun. And then if you walk over the rocket launcher, it switches your weapon automatically into the rocket launcher, but it doesn't do it the other way around. If you have the rocket launcher out and you pick up the nail gun, it doesn't switch weapons. And so it uses the highest bit to determine what your best weapon is. Okay? And so if we make an inventory here, yeah, let's do this. Actually, we can just do this. So we're going to add double-barreled shotgun, axe. We're going to see if we have the axe, and we will at this point. We drop the double-barreled shotgun. This is all what we did on Wednesday. We're then going to pick up the rocket launcher and the assault cannon. Okay. And then we want to do two things. Like, let's print out everything we have in our inventory, and let's find out what our best weapon is. Okay, these are two things that you could use bit shifting to do, right? So what you do is you start off by taking the number 1 and pushing it left 31 times. That's the highest bit, right? And then you check to see, hey, do I have that item? Yes or no. If you don't, cool. Then you right shift 1 time, bloop, and then you check to see if you have that weapon. Yes or no? Choop, choop, choop. And so it's basically going to have a 1 that's moving down each of the bits in the bit field, and for each one that we have, the bitwise and will return true, and then we will print that weapon to the screen. For the best weapon, it's exactly the same code, except once we find a weapon, we stop. Okay? Does that make sense? So if we were to here, let's see out I each time. And you can see it starts off at 2.1 billion. And then runs down the line, 1 billion, 500 million, 200 million, Once we get down to 512, 512 is rocket launcher, remember? So the bitwise and between 512 and our inventory field returns true because that bit is true. So it prints out you have the rocket launcher. And we go down a couple more, you have the assault cannon. Go down a few more, you have the axe, right? And then the best weapon is first one we got, rocket launcher, done. Okay. Order in for the plebs with no weapons. That's right. Yeah, you should have a weapon. Don't be so slow. Does that make sense to you all? So you start with a bit on the high bit, and you just kind of scan down the bit field, and every time that you find a 1, you print out that item, right? So if we were to, I don't know, add the nail gun or something to it. Then you'll see that when we get down to 8, which is the nail gun, we print that out. Now, a common question is, how do you, if you've got all these constants, how do you actually print out the name of the constant? Right? Like, we've set up all these things up here, right? How do we actually print out, like if we have the axe, how do you print axe? And if you have the single-barreled shotgun, how do you print out single-barreled shotgun? Do you know what I mean? Like, how do you write that code? An enum? You could do an enum. In fact, format this a little better. We can probably do this pretty similarly. So an enum, so this basically makes a bunch of constants. Like this code here, like you see it yelling at me, right? Like you already have, you know, a constant weapon axe that's equal to 1. You know what I mean? Like it's literally the same code. The benefit of an enum is that it allows you to do something like this, like actually make a variable of type weapon, and then set it equal to weapon axe, and it will yell at you if you try doing something like setting it equal to 3, because 3 is not part of the enum, right? So you can break things if you want. Like if you wanted to, you could say like weapon axe plus 2 maybe. I don't know. Like, nah, it doesn't like that. You can break it. Like under the hood, an enum, a regular enum is just an integer. There's all sorts of ways you can break it and violate the correctness of it. But in general, the nice thing is like the only values allowed for weapon are axe, single barrel shotgun, things like that. And so if you have like 1024 is not used, you can't set it. Whereas when you use constants, you know, they're just ints, right? So the enum approach is better, really. But either way, they essentially do the same thing, right? An enum is just an automatic way of making a bunch of constants for you. This way is probably not as good. And there's an even worse way. Hashtag define weapon axe to be 1. Right? This is how it's done in C, by the way. And so this is essentially doing the same thing as that, but it's not type safe. So not as good. All right. Basically, this will do a search and replace. Every time you see the word weapon axe in the code down below, it will be replaced by the number 1. And you notice how it doesn't yell at you for redefinition because it's not a variable. It is doing search and replace. And if you do something bad like this, you think you're constant, right? Like, just think about how bad this is, by the way. The preprocessor in general should be used as little as possible these days. C++ has been actively trying to get rid of the preprocessor as part of a multi-decades-long project of getting rid of the preprocessor. It's still needed for some things, but hopefully in the next 10 years they'll finally eliminate the preprocessor entirely, because it's dangerous. Look at this. So if you were looking at this code, you might think, okay, weapon axe is 1, right? Let me just do one of them so you can see how bad this is. Okay. Now, when you hashtag define weapon axe to be 4, everywhere down below the word weapon axe appears, that gets replaced by the number 4. And so the compiler won't even see the variable weapon axe being used. And so if we were to compile this, no warning whatsoever, you can see that we don't have the axe anymore, right? So, not good. Not good. All right, so, yeah, as long as it's the same, then, you know, there it works. It's not good. It's really not good. Okay, so, no, it's dangerous. It's super dangerous. Just, no, don't use it. Enums are better than this, and better than enums. There's 4 different ways of doing this, by the way. Better, I'm going to order them from top to bottom. Better than enums are enum classes, but they don't like being ints at all. So, no. Okay. There is something called like enum class weapon, but when you do that, they don't even want to be an int at all. And enum is actually just an int under the hood. And these things don't even like pretending they're ints, not even on TV. So for our assignment, enum's probably the best, but you can do it this way. More or less the same thing. So enums are great for code readability. The other benefit of an enum is that if you use a switch statement, the switch statement will yell at you if you don't cover all of the possibilities in the enum. The compiler knows you're switching for axe and single-barreled shotgun and double-barreled shotgun and the assault cannon, but you forgot super nail gun. And it will say, hey, by the way, you're checking all the cases except for super nail gun. And you're like, oh, you're right, I forgot. And so enums and switch statements actually go together like peanut butter and jelly. It's actually one of the few cases where I think switch statements are okay. In general, though, I avoid teaching them to new programmers because they always forget to do it properly. And they think it's an equivalent for if, else if, and it's not. Switch statements in C++ are very limited. It's not C#, where you can do string. Like, you can't put strings into a switch statement. Like, so I just don't teach them. You can figure them out later, you know, once you're experienced. They cause, like, trust me, they just cause more problems than they solve. Just use if and else if. So, again, I asked you, like, how do I, no, but like, okay, yeah, we got to for loop that checks every bit, but how do I actually print axe? Like, how am I doing this, right? Like, right now it's printing out rocket launcher and assault cannon and nail gun. Like, how can I go from a variable name to a string? Enums don't help with that. Enums in C++ are terrible. They're stupid. They're really badly designed. In other languages, you can convert weapon axe to a string and it'll print weapon axe. And there's classes you can find on GitHub called smart enums that will do stuff like that. But the built-in enums in C++ are just kind of terrible. There's something that the standards committee, I think, is looking at fixing and making better, but right now they kind of suck. So there's no way of like printing out weapon axe. You have to do it. So how are you going to do it? It's not ass cannon, Hazelton. It's the assault cannon. The assault cannon. Okay. There's also the light assault cannon in Quake as well. Okay. Everything in Python, so you can just use name. Yeah, but C++ can't do it. So how do you do it? How would you do it? Like, how do you think I did it? We got 20 minutes left. Let's talk about this. How can I make a function that if you pass in 1 corresponding to weapon X, it will print X to the screen. And if you pass in 2, it'll print out SBS. And if you pass in 4, it'll print DBS. And if you pass in 16, it'll print nailgun. How would you guys do this if you had to write it yourself? Some good coffee. Map? Map's a good answer. Brute force template. One way or the other, you're going to have somewhere in your code, if it's AX, print out AX. If it's SBS, print out SBS. If it's DBS, print out DBS. And it's a pain. Okay? Because I haven't given you like half the actual things, right? Because like when you select a weapon in Quake, it says, rocket launcher selected. And so you could do this with just a gargantuan if statement block, right? If the weapon is Axe, print out Axe selected. If the weapon is single-barreled shotgun, print out single-barreled shotgun selected. Anybody here want to write that function? Know what I mean? Like, that's a hell of a function, right? Here's the source code, right? Let's see, grenade launcher. There you go. So, Axe, shotgun, super shotgun, nail gun. You see how they're a bit field, right? Light assault, super nail gun, grenade launcher, rocket launcher, lightning, extra weapon, right? So, actually, that's for the HUD. Actually, there we go. So, weapon, grenade launcher, super shotgun, sniper rifle, right? There's a lot of these things. There's a lot of these things, right? So, nobody wants to write it, but somebody has to write it. So let me show you how I'd write it. So I would start off by making a function, and I would call this function string enum weapon to string or something like that, and it would take a weapon or just take an int, whatever. Okay. And so I could do something like this, like if x ended with 1, return x, right? You know what I mean? Because we're going to be getting, ideally, this should just be a power of 2, right? All the numbers should be a power of 2. But I'm still not going to use double equals just in case somebody screws up and passes in something wrong. And then if it's 2, then we do, and this should probably be if that's equal to weapon x, return x. If it's equal to weapon SBS, return SBS. Okay. So am I getting at anyone write that function? I don't. So let me show you how I would write it without writing it. Okay. You guys ready for this? Mark x, mx, y single quote x copies all the lines there, or you can use Mincorelli's favorite thing, which is Shift V to do line select, and then y to select all of those. Copy, paste, 10 more lines. Okay. And I want to turn this into a big if-else-if kind of thing. Okay? So I'm going to show you how to make it a for loop. Nope. This function will takes in like 256 and returns weapon, or just assault cannon, right? Okay. So this is a function that takes in an integer and returns a string corresponding to which weapon that is. Okay? We've got all these things set up, but they're not strings. And there is no reflection in C++. And there's no nice way of doing this, unfortunately. So I'm going to teach you how did I tab all the lines at once? Less than, 5 less than, left shifts 5 times, 5 lines. Right arrow, 5 right arrow, right indents, 5 lines. So if you want to left arrow, shift 5, left indents everything between the curly brackets. Oops, let's not delete that. Write shift 5 is going to write shift everything between the curly brackets, including the curly brackets, I guess. A better way of doing that, though, would be, let's see, left shift 11 left shift. You could do equals shift 5, and then it reformats everything between the curly braces. It's another way of doing that. So what it do is equal shift 5. It's very useful, especially when you're copying and pasting code. Okay. Check this out. Q, record a macro. So I'm going to pick macro Q. So you see at the bottom of the screen there, it says recording at Q. So this says I'm recording a macro, and you can have a lot of macros, one for each key on the keyboard, basically. Capital letters too. I'm just recording Q because, I don't know, why not? QQ, noob, I don't know. So everything I type now is going to be recorded into a macro. And then I can play it back later. And so that means I only have to convert this into an if statement one time. And if I do it right, then I can use that macro and reshape all of my code. I've done this before in like hundreds of thousands of lines of code. I write a macro for one line, and then I apply it to the entire file, and it reformats all of the code in the entire file without me having to do it by hand like a Windows programmer. Okay? So I don't know why Visual Studio programmers like using their mouse and typing everything by hand like a peasant. I don't know. I don't get it. Vim. Once you've used Vim, it's hard to go back. It's hard to go back. Okay. So let's do this. So I'm recording all my keystrokes now. So I have to think about it. There's certain things you want to be careful of when you're doing a macro. For example, not all of these words are the same size, right? So if I were to hit right arrow a couple times, to like go to the end of ax, it wouldn't work when we get to nail gun. So you have to be very careful with how you do it. So I'm going to start off by doing a D2W, deleting 2 words. Okay. And then I'm going to go into insert mode and say if x single at escape. Now my temptation would be to just punch go to the right, go to the right, go to the right a bunch of times, but that won't work because not all of the constants have the same size. So what I'm going to do is hit E to go to the end of the next line, or end of the next word, sorry, not the end of the line. E takes you to the end of the next word, so it doesn't matter how big the word is, it'll take me to the end of it. A to go into append mode, close parentheses, return, double quote, semicolon, escape, right arrow, delete, $, will delete everything off the end of the line. And now I'm going to hit shift 6 to go to the front of the line, and I'm going to front slash underscore to find the underscore there. I want to find the first underscore. I could use shift slash question mark to search backwards, but some of these things have multiple underscores. I want to find the first one, not the last one. So I'm here, I'm going to go right arrow once, and I'm going to type ye, Y-E, like Kanye, right? Y-E copies to the end of the line, or I keep saying end of the line, copies to the end of the word. So that's going to copy ax into the buffer. I'm then going to hit shift 4, $. Caret is beginning of line, $, is end of line, so I hit $, takes me to the end of the line. Back arrow once, shift P to paste, down arrow, shift 6 or caret to come to the beginning of the line. And the reason why you finish at the beginning of the next line is so that every time you replay the macro, the cursor moves to the next line, and so you can just hold down replay and it'll just reformat all of your code. And I'm going to hit Q to save the macro, and if everything's right, all I have to do is replay the macro and it'll reformat the next line the exact same way I did this line. So to replay a macro, it is the shift 2 or the at symbol, and then Q. Yeah, there we go. And at shift 2 will replay the last macro you played. There we go, done. What do you think? I told you, once you learn Vim, you're bigger and stronger and more physically fit. Yeah. And the order, if you want to take notes, here are the notes. I wrote them down for the previous class. All right. So, yeah, so these were all the steps that I typed in. So QQ records macro Q. That's what I usually use when I'm writing a macro that I don't want to use anymore. It actually saves your macros from like one instance of Vim to another. So if I Vim some new file and hit Q, @Q, it actually, all those keystrokes are still saved. It doesn't lose them when you quit and reload. It saves all of your macros between different files and invocations of Vim. And that's why I have @M. That's my macro that generates hello world for me. Okay? So that's why every time you see me start a new file, I type Shift-2 M. I don't know why M, hello world, I don't know. It doesn't make any sense to me. Whatever, it's far away from Q. So I do that, and then it fills in the starter code for me, so I don't have to type it every time because I get tired of typing. Okay, so here is what I did. I started recording macro Q, deleted 2 words, D2W, delete 2 words, I to go into insert mode, I then type X and da-da-da-da. E to go to the end of the next word, right arrow to move right 1 letter, delete to the end of the line, go back to the beginning of the line, that's a front slash, in case you couldn't see that, front slash underscore to search for the first underscore, right arrow 1 time, Y to yank, that's what Y stands for, yank to the end of the word, so that's going to copy axe or rocket launcher or whatever, $sign goes to the end of the line, left arrow to get back in between the double quotes, P to paste, and Shift P pastes before the cursor, P pastes after the cursor, so you can pick which one. Down arrow to go to the next line, Shift 6 to go to the beginning of the line, and remember, you always want your macro to end up at the same place it started, but 1 line down, so that you can just sit there and hold down Shift 2 and watch the code go like that. And then Q to stop recording. And then you can play the macro by saying Shift 2 @Q. And then once you've played it once, you can hit Shift 2 a bunch of times, and it will replay the last macro over and over again. So you just hold that down. It'll just reformat all of your code. And if you want to, if you want, you could do like 100, like that, and it'll do it on 100 lines. I usually like to watch it, unless I'm doing it over like 100,000 lines. I usually like to watch it as it goes to make sure I don't go too far. All right. So, yeah, but I've done this on like 100,000 lines of code before. You are not limited to Q and Z. Every key on the keyboard can have its own macro defined for it, including Shift, right? So that's why I say QZ or QQ or whatever. Like you can have every letter can have a macro. Shift Z can have a macro. So you can have quite a lot of macros defined. I don't know how you'd keep them all, keep track of them all. But macro M, maybe that's why I picked M. Macro M is my thing that just generates hello world from scratch, basically. To Q is to start recording the macro, yes. Q starts and stops recording a macro, plays a macro. And these are saved, like I said. They're actually saved to disk. Okay. Yep. So that's basically it for today. Let's see if we got 5 minutes left before the workshop. And or not XOR shift, bitwise and. Yeah, so each pair of bits gets ANDed together, or each pair of bits gets ORed together. Not flips the bits. 4 1s and 4 zeros becomes 4 zeros and 4 1s. XOR, anytime you have a 1, it flips the bit. Anytime you have a 0, it leaves it alone. Shift, every time you left shift, it's like multiplying by 2. Every time you right shift, it's like dividing by 2. And zeros fill in the gaps. What is the name of this PowerPoint? This is called Bit Operations, Lecture 20. So you can set bits with bitwise OR. You can delete bits using AND with the not. And you can check to see if you have it using AND. And that is bit operations, and you will do more with them in 26 and do more with them in 45. And like I said, there's a lot of code out there that if you were just to look up like how to do something like Octal, you will see that there are no single standard. Well, that's not helpful. Man, open. Yeah, there we go. You see that? So the system call open takes flags that are the way that you want to open the file. Do you want to read it, read only mode, read and write, whatever. And so you can see that fopen translates from somewhat more human readable to the system call thing. So if you open it in write mode, it opens in write only, bitwise ORed with create a file, bitwise OR with truncate a file, which means if the file exists already, set it to size 0. Create means if it doesn't exist, create it. A is append mode, so it reads it open for writing. It'll create the file if it doesn't exist, but rather than truncating it, oops, I just right-clicked. Rather than truncating it, it will add to the existing file. That's append mode. That's read and write mode, read and write, and create the file if it doesn't exist, and truncate it, append mode. And so you can see that like these bitwise operations are used all the time for doing things like setting options. Like if you've got a lot of different options, you can either have a function that takes like 50 booleans, or you can take one bit field, you know, a 64-bit bit field, I guess in that case, and each bit would mean read mode, write mode, that kind of stuff. And it's very commonly used. So it's just the kind of thing that you're going to get used to. We'll probably do a homework assignment on it, so you'll get some experience with it. Was this table made with in curses? Probably not. Trough is the way that man pages are used, something like that. Some version of it. There's a lot of versions. So it's like a markup format that man pages are made in. Will this file be in public? Yes. Bitfield or bitwise? It's not this one. Yeah, this is our code from last time. Save the thing and deleted those comments out of it. So. Give you some cheat sheets on how bitwise OR and bitwise AND work. All right. So copy main.cc up into public / bitwise.cc, make it world readable. And there we go. And it's time for some sea shanties. So there you go, everyone. I'm going to log off now and prepare my singing voice. I have to go me, 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 me. Not really. All right. See you in a minute.